This is PRK Physics, our YouTube channel, PRK Physics. Now, today we are going to discuss about faulty barometer. Actually, do you know what I mean by barometer? Yes, many of you may know about it. Barometer is an instrument used to measure pressure of the atmosphere. To measure the atmospheric pressure, we use the device called barometer. But here we are going to discuss about faulty barometer. That means the barometer which will not give the correct reading or true reading. So let us discuss about it. Actually, while measuring the atmospheric pressure by using barometer, what we have to do is, let us take one glass tube. Of course, here I am taking one long glass tube. It is closed at one end and open at other end. It is filled with some part of mercury. It is filled with mercury. Okay. Now, let the open end is closed with a thumb and it is placed inside the mercury vessel like this. So, this is the glass tube I am placing here. So, it is inverted and placed inside the mercury vessel by closing the open end with our thumb. After that, just remove your thumb. Then, the space here, this is called Torricelli's free space, or it is nothing but vacuum. It is also called as Torricelli's free space. Here, capital L is nothing but length of the glass tube above the mercury in the vessel. This is called the level of mercury in the vessel. So, above the level of the mercury, L is nothing but length of the glass tube above the mercury level in the vessel, and the capital H, that gives us atmospheric pressure, height of the mercury column. Height means above the level in the beaker. Okay, this capital H gives us true atmospheric pressure, but actually this is, I told you, this is nothing but vacuum. So, this is also called as Torricelli free space. So, suppose during this process, that means I am closing the open end with the thumb and it is inverted and it is dipped inside the mercury. During this process, suppose if some air is leaked in it, by mistake, if some air is leaked, then we will not get the correct reading. Then the barometer show faulty value. So, that is called faulty barometer. Suppose the height of the mercury column now here is HF. HF means faulty reading of the barometer. HF means faulty reading given by the barometer. Actually, you know, pressure can be measured in terms of height of mercury. 76 centimeters of mercury column, that is one atmospheric pressure. So, in terms of mercury, height of mercury, we will express the pressure. So, let HF be the faulty reading and HT be the true reading of the barometer. True reading means actual atmospheric pressure, HT. HF means faulty reading, and actually this is the concept application of Boyle's law. I think you know what is Boyle's law. Boyle's law, at constant temperature, the product of pressure and volume is constant. So, P into V is equal to constant. This is called Boyle's law, and you know that I am taking a glass tube which is having uniform cross section. What do you mean by uniform cross section? Area is constant throughout the tube, throughout the length of the tube, area is constant. That is called uniform cross section. So, I am taking a glass tube which is of uniform cross section. Therefore, I can write volume expression. It is of cylindrical shape, that's why I can write area into length. So, in place of volume, I can write area into length, that is equal to constant. This is nothing but Boyle's law. So, let me use this expression. So, here A is constant. I can write like this. P stands for pressure. L stands for length of the vacuum. Got it? So, P into L is equal to constant. This is the Boyle's law. We need to apply this Boyle's law here. So, here P nothing but pressure of the air which is trapped inside the glass tube. P nothing but, what is the expression for the pressure of the air? It is nothing but difference between the true reading and faulty reading. That is called pressure of the air. Suppose what happens if there is no air is trapped? Simple. P becomes equal to HT, but it will give exactly the correct reading. So no need to discuss all these things. But we need to get the correct reading. Even though it is showing faulty reading, our aim is to find out the actual atmospheric pressure. That's why we are using Boyle's law. Got it? So pressure of the air trapped. P stands for pressure of the air trapped inside the glass tube. Expression is HT minus HF, because we are expressing pressure in terms of height of mercury. And what is the length of the air, length of the space, or length of the air means, actually I told you, no, capital L is the total length of the glass tube above the level of the mercury. Capital L minus, I told you the reading, nothing but it shows faulty reading, L minus HF. L minus HF means nothing but total space, length of the total space, nothing but length of the air, because if some even small portion of air is entered in it, then the air will occupy the total space. So length of the air column is L minus HF. Pressure of the air trapped inside the glass tube is HT minus HF. So let me substitute these two values. I know the formula by using Boyle's law, P into L constant. In place of P, HT minus HF into, in place of L I can write capital L minus HF constant. You need to remember these expression. We need to remember these values. That means HT means true reading of the atmosphere. HF, faulty reading given by the barometer. Capital L, length of the glass tube above the mercury level in the vessel. HF, faulty reading given by the barometer. So suppose if we get two values, let me call the true reading as H1, faulty reading in the first case H1 dash, capital L minus H1 dash is equal to, for the second combination I can write second reading. If the same experiment is repeated, we get some other values. Then H2 minus H2 dash into L minus H2 dash. So from this I can find very easily the true atmospheric pressure. Generally he will give you the length value, H1 dash value, H2 dash value also he will give you. He will give you H1 and you will be asked to find H2. Okay, basing on this we can do the problems. And let me do one problem basing on that concept, faulty barometer. Look at this problem. A faulty barometer tube is 90 centimeters long and it contains some mercury, some air above mercury. The reading is 74.5 centimeters. When the true atmospheric pressure is 76 centimeters, what will be the true atmospheric pressure if the reading on this barometer is 74 centimeters? So actually this faulty barometer concept is based on Boyle's law. I think you know that. At constant temperature, the product of pressure and volume remains constant. And you know, for a cylindrical shape, volume is nothing but area into length as constant. Since area for uniform cross section tube, glass tube, area is constant, I can write P into L is equal to constant. So what is P? True value H1 minus fault value H1 dash into capital L, that means length of the glass tube minus fault value is equal to, again for second reading, true value is H2, its fault value is H2 dash, L minus H2 dash. So here H1, H2 are true values, H1 dash, H2 dash are faulty values given by the barometer, capital L is length of the glass tube. So here H1, true atmospheric pressure, is given as 76 in the first case, and H1 dash, its previous reading is 74.5, and capital L, length of the barometer tube is 90 centimeters, and H1 dash is nothing but 74.5, that is equal to H2. We need to find out the true atmospheric pressure. This is the parameter we need to find out, and H2 dash given as 74 into capital L is length of the tube 90 minus H2 dash is 74. So here only unknown parameter is H2. So here the difference is I can write 1.5, and 90 minus 74.5, it is nothing but 15.5 is equal to, here it is H2 minus 74. 90 minus 74 means 16. Hope you can do this problem, very simple. 16 comes to this side and division, you are going to get H2 value very easily. Okay.